Alright, so here is our integrator circuit we're going to have. So we have this large power resistor here, and we are going to read the voltage across this meter. So we're going to have a voltage. So we're going to come from the ground terminal is going to go to the ground here. And then we're going to have the voltage. So we're going to have the voltage, which is going to be up to 50 volts. And so we have to do this connector here. So here is our converter. And you see we have pin 12 is always the input ground or input common right here. And if we're going to have 100 volts, then we have to be here at pin 9. So we're going to have our 50 volts. So pin 9 is going to connect over here to the hot side. So right here to right here. So pin 9 and pin 12 to ground on our voltage converter, which is our first converter. And then our second converter is going to be wired up to the shunt. So this is our shunt. And so we've got our ground terminal, which again is going to go to pin 12. And our input, our current input, if you can read that, is right here is pin 10. So the other side, so the hot side is going to go over here to pin 10 on our converter. And then the common side is going to go back to the common side of our power supply, and the hot side of our power supply is feeding into our resistor. So here is our wiring. I've got it set up here so that I'm going to use the second supply, output B, on my power supply. So I have my hot coming here, and the hot then is going directly into my resistor. So this is my 5 ohm 220 watt resistor here. And so I've got the lead, I've got the red lead going into the hot, the positive there. And then what I did was I took an alligator clip and I stripped off quite a bit of wire here so that I could wrap around that alligator clip about 3 times. It's not showing real well in the video here, but I've got that wrapped around. I've got this see if we can focus there. I've got this wrapped around the alligator clip about 3 times so that it'll stay pretty well. And then I've got the alligator clip clipped on here to what I've declared to be the positive side of my resistor. Okay, so I've got the positive lead coming over here using the alligator clip, and I've got it clipped on to the positive side. We're only going to have about 25 volts. The power supply can only do a max of like 30 volts. So it's not a real high voltage, and as a matter of fact, because the resistance is so low, the power supply, the voltage really won't get over about 12 volts. So it's going to be a low voltage connection. So it's going to be a high current connection, but it's going to be a low voltage connection. All right, so then I'm going to connect my voltage. I've got to connect my positive voltage to this positive connection. All right, so this converter here on the left is my converter 1, which is going to be my voltmeter. So I have the red lead attached to pin 10 or pin 9, excuse me, pin 9, which is rated for 100 volts, because I'm going to use I'm not using the 100 volt scale, but I'm using the 50 volt scale. So you got to pick the volt reading that is within the range. So 50 or 100 volts go into pin 9. So we're going to now take this here, and this is just a voltage reading, so this is a high input, so I'm just going to clip this on here. So I'm just going to clip this wire right underneath that alligator clip. Okay, so right underneath that alligator clip, I just clipped that wire on there. And then the common side, remember that the common side from the resistor is going to go to the shunt and into the meter. So what I've got is I've got the common side of my voltmeter. I'm using orange there because it's not quite ground, right? Because we're going, our current meter we have here, we have our current and our shunt before the ground. So here's my ground wire, and this is where the shunt is. So I decided to use orange there, so I'm going to use orange. So I'm coming out of my voltage, coming out of my voltmeter, common of my voltmeter converter, and I'm going into the positive side. I'm going into the positive side of my ammeter. So remember, this converter we're going to be using to measure current, so that's going to be our ammeter. Now remember that this meter here, this meter is set, it can only read 1 milliampere. All right, so, but we're going to have up to, at least theoretically, up to 5 amperes flowing through there. So 4.999 milliamps would flow through the shunt if 1 milliamp is running through my converter. So I've got, these are connected, so the voltmeter negative is connected to the positive of the voltmeter, and then I have my shunt. Here's my shunt, that little blue wire, that's my shunt. So there's the shunt, and I'm using a blue wire for that, that's my shunt. And then the positive side, the orange wire, the positive side now is what needs to connect to the negative side of my resistor. So again, I have a really long, I've stripped the insulator off of there, so it's very long, and I'm going to use an alligator. I'm going to use alligator clamp to attach that. So we have this, I had stripped it fairly long there so I could wrap that around the alligator clip, and then I'm going to clip that onto the opposite side, or the negative side of my resistor. Now the resistor of course doesn't have a, I could use either side, but I've just set it up so that my left side is my ground, and the right side then is of course is my positive for my resistor. But that is the wiring. Okay, so we have, again, let's look at this again. I have a voltmeter here on the left. Now these are converters. When I say it's a voltmeter, it's configured to read voltage, so I've set the dip switches so that this converter on the left can read a voltage between 0 to 50 volts. And this converter is set up as a ammeter, so it's going to read current, and it's going to be reading current. The ammeter technically is only going to be reading a current between 0 to 1 milliamp, but then I have this shunt connected here so that the shunt in parallel with the ammeter we can have a combined current of up to 5 amperes through this meter. So even though this meter is only set up and is only going to be reading up to a maximum of 1 milliampere, if this converter is reading 1 milliampere, With my shunt, that means that we have a total of 5 amperes running through the resistor. So then we can, we've got our channel 0. So the left one's going to be channel 0, and it's reading, this converter is converting this voltage. And the voltage, again, can be anywhere from 0 to 50 volts. But we're converting that into a 40 milliampere input that we're then going to feed into channel 0 of our PLC. So here's our PLC, and we've got this terminal block set up here. So the pins 17 and 16 are going to be sending the 4 to 20 milliamp signal. The converter's feeding the 4 to 20 milliamp signal into channel 0, representing a voltage. And then the other converter is reading a 4 to 20, or sending a 4 to 20 milliamp signal, which is going to correspond to 0 to 5. So if it's feeding out 20 milliamps, then that means there's 5 amperes flowing through my resistor. And 1 milliampere is actually going into the converter. The rest of it is going through that little shunt, that little blue wire there.